Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Natasya Aqilah binti Muhammad Noor, and a very good morning to all my students. Okay. Today, I want to teach you all the chapter 11, which is isometric transformation, and I'll focus on 11.2, which is translation. So, how are you today? I hope you all will feel good in this class today. Okay. We move to the translation. Okay. For the learning objective of this class today, at the end of the lessons, you all will get recognize translation, describe translation by using various representations, including vector form. Third, determine the image and object under a translation. And lastly, you all will solve problems involving translations. So I hope you all can get what I'm teaching today. Okay. Next, we move to the definitions of translation. Okay, what is translation? Translation is the transformation which moves all points on a plane to the same direction. Okay, I will highlight it. The same directions. Okay. The size, the shape, and the orientation of the image are the same as that of the original object. Okay, for the image, we will get the same size and the shape, and the orientations will be the same as the original object. Okay, next. The same orientations means that the object and image are facing the same direction. Okay, what is same orientation? It is the object and the image are facing the same direction. Okay. We look at the translations. We look at this picture. Okay. We see that the object and the image have the same size and the same shape, and it is the same orientation. Okay. Every point in the object is moved the same direction and the same distance to form the image. Okay. Look at this object. Object is before translations and the image is after translations. So you all have to know what is object and what is image. Okay, because we will make the exercise after this. So you all have to recognize what is object and what is image. Okay, we describe translations in terms of number of units moved to the right or left and the number of units move up or move down. Okay. Next, I will be explaining what is this. Okay. So next slide, we move to the example. Okay. For example, this translate to 4. Okay. Okay, 2, 4. Translate 2 units right and 4 units up. Okay. For this bottom number, we say it right, right or left. It is represent the number of this top number, which is 2 units to the right and 4 units to up, move up. Okay. So this object will form this image using this vector number. So this vector number is very important to you all to know. Either it is right or it is left, and if it is moved up or moved down. It is based on negative or positive. Okay. So we move to the transitions represented by column vector or matrix. Okay. Okay. This is what we talked before this. Which is this is a column vector. color vector to far. Okay, the top number represents the right and the left movement. And a positive number means moving to the right and the negative number moving to the left. Okay, so for this 2, 4, okay, for this 2, for this number of 2, for this the top of the number, which is 2, right or left, it is represent to the negative or positive of this number. And for the bottom of number, represents up or down of the movement. Okay. A positive number means moving up and negative number means moving down. So for the 4, it is move up because it is positive number. Okay, next we do some example. Okay, write coordinates of the image of A, -2, 4, under the sensation for 3, for -3. So we look at the object A, -2, 4. Okay, this is A, -2, 4, which is translate to 4. 4 negative 4, which is means 4 to the right, 4 units to the right, and -3, -3 units to move down because it is negative. So we just move the point 1, 2, 3, 4, and -3, which is 1, 2, 3. So we get the image is 2, 1. So it is very easy because we know the translation vector. If we recognize what is the bottom, what is the top, we can translate this vector as easy. Okay, easily. Okay. Okay, next we move to the B object, which is 1, -2, and the translation is -5, 3. Okay. Because of this number is negative, we move to the left. Okay. 1, 2, 3, 4, 5. Okay, for 3, we move up because it is positive. 1, 2, 3. So we get a -4, 1 of the image. Okay. Um, do you all get what I'm teaching? I hope you can understand what I'm teaching now and you will be able to catch up. Okay. If you have any problem or you have any question, just ask me. Okay. Next example. Okay. This is this question want to know what is the vector that translates the object to the image. So the question is, how is triangle ABC being translated to triangle A prime B prime C prime? Okay, so we just move the point to get the vector number. Okay, firstly, we look at the C object. We move to the right. 1, 2, 3, 4. Okay, 4 to the right, and move to the down to know what is C prime. Okay, what is the vector that C to C prime. Okay, so we get 1, 2, 3, 4, 5, 6, 7, 8, 9. So because this is moved down, it will be -9. So the vector is 4, -9. 4 for top and -9 is for move down. Okay. I hope you can understand how the translations process and how we will get the vector number. So you can do the exercise that can improve your learning skills, improve your skill of translation. So I hope you can understand. Yeah. Next example is example 3. Okay, we look at these questions. Firstly, we look at the object A, B, C, D, and we want to translate to this image. So this example, right? Okay, this figure like 7 units to the left and 3 units down. Okay, so if we want to check whether it is true or not, so we move D. Okay, D to D prime. Okay. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. Okay, so D prime, it is true that this translation is sevens, negative sevens and negative 3. So for A, okay, next for A, 1, 2, 3, 4, 5, 6, 7, and 3, 2 down. 1, 2, 3. So A, the object of A will translate to the image of A prime. Okay, next B. 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3. So it is true. B prime is the image of B of object B. Okay, for lastly for C. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. So negative 7, negative 3 is the vector of this example. It is be proven in this example. So you all have to make many exercise to know the translations more, okay, to improve your translation skills. So I hope you can make many exercise as you can with these translations, because it is very easy to score in your examination. So you all have to be more hard work for this subtopic. Okay, next we will move to the GeoGebra. Okay. Okay. GeoGebra to prove the translation. So I will open the GeoGebra to prove it. Okay, so you all have to open the GeoGebra Classic. You open on Google. Okay, so if you have any questions about the manual of the translation, you just ask me. And if you have any questions, just WhatsApp me. So I will explain to you all if you don't understand. Okay, so we move to the GeoGebra Classic. Okay, GeoGebra Classic. Okay, we use this as a teaching tools today, because I want you all to know the translations using this GeoGebra. Okay, so it is very easy to you all to use this GeoGebra, because these applications is very easy to use. Okay. Okay. Firstly, okay, we will move to the GeoGebra application, which is these applications is very easy to use. Okay, firstly, I want you all to make the polygon. Okay, you click this polygon, and you just draw the triangle. Okay, just draw the triangle. And next, I want you all to click this, because I don't want to make a polygon anymore, but I want you to make the point D, which is we have A, B, C, and we want the point D. Okay, D. I want it is on origin. It is 0, 0. Okay. So this point D. And next we want a point E. Which is this is we want um, we want to 5 to the right and 3 units to the down. So we make it E is equal to 5 negative 3 because we want to translate it to 5 negative 3 and we have to click the enter. So we have D and E. We have 2 points and 1 polygon. So next we want to make a vector because we want to translate this polygon. We have to click the line menu and we click the vector. So we click the D point to E point. Okay. So the vector is 5, negative 3. So before this, we know that 5 is to the right. 5. The upper number that we see here is the horizontal translations, and positive to the right and negative to the left. And then for bottom, it is vertical translations, which is for this case is going down because it is negative, and if positive, it is going up. So since you drawn the polygon and the vector, so you are ready to translate this polygon. So next we go to the transformation menu and we choose translate by vector. Okay. Okay, this is translation menu, transformation menu, and you choose the translation by vector. Okay. I will click to the polygon, the interior polygon, and the vector. Okay, you will see this is the image of the object. So for this case, um, if we want to check either this is a translation of this object or not, okay, so we will do the manual, okay. So see, we just move the point, okay. 1, 2, 3, 4, 5, okay. 1, 2, 3. So we got B prime, B prime. So A, okay, for A. Next for A, 1, 2, 3, 4, 5, and 1, 2, 3 to down. Okay, so we got A prime for the image. And C, we move to the right, 1, 2, 3, 4, 5, and 1, 2, 3 to the down. So we prove that this is image, this object, this polygon is the image of this object. So it is very easy to you all to use this GeoGebra as the learning aid that you can check either this is image of the object or not. So we will move to next. Um, we want to make this object an image. Okay, next. Okay, we will move to the next questions. So we just click the polygon and the point that you want. Okay, I hope you can understand what I'm teaching. So this is the object. Next, we want the origin for E 00 and E. I'm sorry, this is D 00 and E. I want -3, negative 4 and 5. Negative 4 and 5. Okay, because I want -4 to the left and 5 to move up, and 5 move up. Okay, so we click enter. Okay, so we get this. Next, we click the vector D to E. Just click the point of D and E, and we got the vector. So we want to translate. We click the transformation menu and we click the translations by vector to translate this object. So we just click the interior of this object and the vector. So we zoom out to see the image of this object. So you will see, okay, this is object and this is image. So if we want to check again, okay, you just do the manual translation. We just move this object and we will get the same object at the same shape and the same size. Okay, so it is proof that this translation is very easy to you all to use. Okay, you can either use this GeoGebra to check your your translation. Okay, after this. Okay.
Okay, next, I want to prove that the size, the shape, and the orientations of the image is the same of the original object. Okay, so firstly, we draw the triangle. We click on polygon and we draw the triangle. Okay, so this is the triangle. So I don't want this. So we just click for the label and we don't want the label of this side. Okay, next we want to create a vector because we want to translate. Okay, so we just click on vector and we create from this to this. Okay, so the image, the vector of these translations is 1, 2, 3, 4. 4, 1. Okay, -4, 1. The vector is -4, 1. Okay, so because we make this, we can get the vector beside this. Okay, so we want to translate. We just click on line menu and we click on translations by vector. Okay, we click the interior polygon and the vector. So we get the image of this polygon. So I want to prove that the size, the shapes, and the orientation of the image are the same as the object. So what I want to do, we click on move and we change the shape of the object. Okay, you can see. Okay, you can see that the image also change if I change the shape of the object. Okay, and if I make it like this, it will move like this too. Okay, so we want to move the vector and the image and the object will change. So it is proven that the size, the shape, and the orientations is the same as the original object. So for this is very easy for you all to know what is the image and the object of this translation. If the question just have the vector and the object, you all can use this GeoGebra to prove it, and you all can also do the manual. Okay, because it is very easy to you all to to make these translations, because we just click on this polygon and we can translate it by the vector. So I hope you can understand what I'm proving, and you can also try on your laptop. Okay, so I want to create another one polygon. So we move and we click on the new. Okay, so I want to make one more polygon to prove the same shape, the size, and the orientations of the object is the same as the image. Okay, I don't want the label 2, and we just click on the label because we don't want label. So we take the vector is the same before this, but the vector is from A. Okay, so we can see the image like this, and we translate this. We click translation by vector and click on polygon and the vector. So we get the image, and we just move the object, and the image also move because it is proven that the object and the image are the same. Okay, for translation. So that's all for me. Thank you.
If you have any questions regarding these GeoGebra applications, you just ask me. Okay, just ask me in WhatsApp group. Okay, and I will be explain to you all what you don't understand, and I hope it is clear to you all to use this GeoGebra, because it is just easy method Okay, thank you for hearing, for lending your ear to me, and I wish you all good luck in this subject. Okay, that's all for me. Thank you, and I hope you can recognize the translation, and can make the exercise in the book, in the textbook, and send me in WhatsApp group. You all can make the translation exercise, which is for which is question 4, and send me in the WhatsApp group by 6 p.m. today. Okay, thank you. Okay, that's all for me. Thank you, everyone.